Okay, so now that we know a little bit about correlation and how it differs from some comparison testing, let's go ahead and talk a little bit about variance versus covariance. So we've used the term variance a lot in this term, and we've calculated it in a number of different contexts. But really remember, variance tells us by how much a score deviates on average from the mean for a single variable. And we know that variance, represented in the squared units of the metric, is very closely related to the sum of squares total. As a matter of fact, we know that it is the average of the sum of squares total, and it is in squared units of the metric that we can unsquare through the square root process and get it back to something that we called standard deviation, which was the actual measures of the unit. And so this is done for a single variable, however. And so when we talk about correlation, we're interested into a new concept that is known as covariance, which is going to tell us how much scores on two variables are differing from their respective means, and how we might be able to determine something that's known as cross products, meaning how much of the variance in each of these variables might actually overlap and be tied with each other. And so, if we take a look at the traditional variance formula, you can see that variance is simply computed as the sum of the squares total divided by the total sample size, n, minus 1 degree of freedom. That's been the same all term long. But when we talk about covariance or shared variance, we're trying to calculate the error between the mean and each subject's score for the first variable. So effectively, we're trying to determine the deviance of each person's score from the average score. And then we're going to do the exact same process for each person's score minus the average score for the second continuous variable, the criterion. And then we're going to multiply the deviance from the X scores by the deviance of the Y scores. And when we do that, we're going to develop a new term called cross products. Okay, and so what it is, it's taking the deviance of all the scores for each person, a person's deviance for X and the person's deviance for Y, multiplying those deviances by each other, and you're getting the cross product for that person. And so when you do that, you can add up all the cross products for all the participants in your sample, and you can get the sum of the cross products. And then, yes, once you have the sum, you can determine the average of the cross products, which is what covariance generally represents. And so if you take a look at this formula, the cov, C-O-V, represents the covariance of X and Y, and it is simply the sum of the cross products divided by n minus 1. But there are some general problems with covariance that we need to be made aware of, and that is that we are really dependent upon the units of measurement that we are collecting. To give you an example of this, let's say that we have two variables and they are measured in one unit, might be 4.25, but if the same scores are converted to another unit, the covariance could be 11. A good example in the health sector would be looking at something like cholesterol. You can represent cholesterol in milligrams per deciliter, or you can measure cholesterol in terms of millimoles per liter. And so what this is really flagging here is that depending upon if you're representing your data in milligrams per deciliter or millimoles per liter, your covariance might be dramatically different. And so some of the best ways to determine this is by trying to standardize those units as much as possible. And so the solution to using this covariance problem is to divide the covariance by the standard deviation of both variables. And this is going to produce the test statistic for correlation, which is the Pearson's product moment correlation coefficient. And this is a standardized unit of measurement that works across all kinds of variables, which is why it's very powerful. So I hope this second video was really helpful. In the next video, we're going to go ahead and talk a little bit about how you go through the process of conducting a study with a Pearson product moment correlation coefficient as the desirable test statistic. So we'll see you there.